We have the third day of vector algebra. Let us continue today's topic. Show that the vector I plus j plus k is equally inclined to the coordinate axis. You know, the angle between two vectors is theta. Angle between two vectors a and b is theta. If cos theta is a dot b upon magnitude a magnitude b. What is the angle between this vector x and I? It is x dot I upon magnitude x into magnitude I. That is actually the angle between them is nothing but the direction angle between vector and the coordinate axis, nothing but direction angles. We can easily find magnitude of x is root 3, direction cosines, if OP is a vector r, then direction cosines is x by magnitude r, y by magnitude r, z by magnitude r. You can simply apply x dot I by magnitude x into magnitude I, and magnitude r into magnitude I. R dot I, what is here? If this is r, here it is taken x, the r. If this is vector r dot I will be simply 1 by magnitude of r. Here, what is L? 1 by root 3. M is 1 by root 3. N is also 1 by root 3. You think of the how we get the direction cosines. Direction cosines alpha, beta, gamma are angles made by vector r with OA, OX, OY and OZ. What is angle made with by the vector with OX? With x-axis, that is r dot I by magnitude r. R dot I here it is x upon magnitude r. So here x is in here, this x y is the coordinates or the components, I component, j component, k component. Here it is 1 1 1. So magnitude of x is here root 3. So L will be 1 by root 3, M will be 1 by root 3, N will be 1 by root 3. That means L equal to M equal to N, which implies cos alpha equal to cos beta equal to cos gamma, or alpha equal to beta equal to gamma. That is angle made by the vector with OX, OY, OZ are same, equal. Okay, that means the vector I plus j plus k is equally inclined to the coordinate axis. Now we come to another main point, the product of two vectors. What we have seen earlier is only the scalar multiplication. That means multiplication of a vector with a scalar. Here we have scalar product or dot product. That means product of two vectors which results in a scalar. Product of two vectors which results in a scalar. That's why we call scalar product. And this is denoted by a dot, so we call it dot product. We define for non-zero vectors a and b. A dot b is defined as magnitude A into magnitude b into cos theta, where theta is the angle between vectors A and B. Theta will be any number from 0 to pi. A dot B. Okay. In case if any of A or B is 0, then this theta itself is not defined. But A dot B is defined as 0. Theta is not defined, so this definition is not valid if one of the vector is 0 or both are zeros. Then we define A dot B as, in this case, we define A dot B as 0. Properties of scalar product. A dot B is a scalar, right? It's a number. A dot 0 is 0. A dot vector 0 is a number 0. 0 dot vector is also number 0. 0 dot 0 is also number 0. A dot B and B dot A are one and the same. If A is non-zero, B is non-zero, then A dot B can be 0 only if cos theta is 0. That means theta is finite. That is, A and B are perpendicular if and only if A and B are non-zero vectors, then A dot B equals 0 if and only A and B are perpendicular to each. IWF means if and only if. A dot B equal to 0 implies and implied by A is perpendicular to B, where A and B are not both non-zero. If one of them is 0, then A dot B is obviously 0 without being any direction. If theta equal to 0, that means A and B are same direction, then A dot B is magnitude A into magnitude B because cos 0 is 1. So hence we can say A dot A, if theta is 0, A dot A is magnitude A square. Okay. In case if theta is pi, then cos theta is minus 1. So in that case, A and B are in opposite direction. So A dot B will be minus magnitude A into magnitude B. Further, we have I dot I is magnitude I squared. Magnitude I is 1. So I dot I is 1, J dot J is 1, K dot K is 1. Whereas I dot J is 0, J dot K is 0, K dot I is also 0. Distributive property A dot B plus is A dot B plus A dot C. Lambda A dot B is A into A dot lambda B or lambda into A dot B. If theta is angle between two non-zero vectors A and B, then cos theta will be A dot B upon magnitude A magnitude B. Now look, very important point. If A is A1 plus A1I plus A2J plus A3K, B is B1I plus B2J plus B3K, then A dot B, if you apply the distributive laws, A1 B1 I dot I plus A1 B2 I dot J is 0, J dot K is 0, K dot I is 0, and I dot I is 1. Applying that, it is nothing but A1 B1 plus A2 B2 plus A3 B2. Components are multiplied. Scalar. So scalar components are multiplied. It's a scalar. A dot B, direct multiplication of the components and addition. So A dot A itself will be A1 plus A2 A2 plus A3 A3. That is A1 squared plus A2 squared. It is called B dot B. So A dot A is magnitude A squared. If you want magnitude A, then under root A dot A. Magnitude A will be here. Magnitude B. Correct? And cos theta will be A dot B upon magnitude A magnitude B. Cos theta will be 0 means A1 B1 plus A2 B2 plus A3 B3. Numerator will be 0. That means the two vectors are perpendicular if A1 B1 plus A2 B2 plus A3 B3 is 0. This is valid only when A and B are non-zero vectors. If A equal to 0 vector or B equal to 0, then theta is not the function. If theta is pi by 2, obviously cos theta is 0. A1 B1 plus A2 B2 plus A3 B3 is 0. If theta is 0 or theta is pi, A1 upon B1, that means the components are proportional. If theta is 0 or pi, that means if two vectors are either in same direction or in opposite direction, their components are proportional to each. Projection of a vector on a line. If theta is angle made by the vector AB with a given direction L, then projection of AB on L is a vector P with magnitude AB cos theta. Suppose I have a vector L here and I have a vector AB here. Suppose this is vector AB, or again this is A and this point is B. Then projection, if you take the foot up perpendicular of that here on this line, foot up perpendicular of A and B, foot up perpendicular of A and B, that you can say, suppose it is P and Q. The vector PQ is a vector projection and the length PQ is scalar projection. When I say simply projection, it is only the scalar projection. Okay? And that could be in the same direction if the angle is acute, or if A and the AB and L are in same direction, and if the projection will be the opposite direction if they are in the opposite direction. See here, L and AB, the angle is acute angle, the projection is now vector AC. If this is the case, angle is obtuse angle, the projection is AC in the opposite direction. Here again, projection is AC in the opposite direction, whereas here projection is vector AC in the same direction. Okay. Now, if you take the length, AC is vector P, the projection in all the cases. But if you take the length, that is actually the scalar projection. So projection vector or vector projection of A on B is A dot B multiplied with unit vector. A dot B means A dot unit vector B, A dot B cap multiplied by B cap. You can easily observe what is A dot B cap. A dot B cap is A dot B upon magnitude of B multiplied by B cap. B cap is B by magnitude of B. That is A dot B by magnitude of B squared into B. A dot B itself is A dot B cap itself is A dot B by magnitude of B into B by magnitude of B. So A dot B by magnitude B squared into B. But normally, when I simply say projection, if the projection vector is not given, only projection, that means actually it's a scalar projection. It is A dot B cap, or projection of A on B is A dot B upon magnitude of B. What we mainly look is at this point, which one? Projection of A on B. Normally, the scalar projection is not coming to your questions. When I say simply projection, it is projection of A on B. Projection of A on B. That is a scalar projection. If it is projection of A on B is A dot B by magnitude of B. Projection of B on A will be B dot A by magnitude of A. And if A is perpendicular to B, then A dot B is 0, the projection is 0. And if A is 0, if A itself is 0, that means if 0 is vector is projected, projection is also 0. This is a scalar quantity. Only vector projection, which we are not dealing in our topic now. When scalar projection, it is a projection. It is A dot B by magnitude of B, projection of A on B. If A is perpendicular to B, projection is 0. If A equal to 0, projection is 0. We can't project on 0 vector, so B cannot be 0. So remember, projection of A on B is A dot B upon magnitude of B. If alpha, beta, gamma are the direction angles of vector A, then the direction cosines will be cos alpha is A dot I by magnitude A magnitude I. That is simply A1 by magnitude A. Cos beta will be A2 by magnitude A. Cos gamma will be A3 by magnitude A. You have to remember this. So you can easily observe that magnitude A cos alpha, magnitude B cos beta, magnitude A cos alpha, magnitude A cos beta, and magnitude A cos gamma are the components of the vector along OX, OY, OZ, which are the projections. The components of the vector are the projections. Components are the projections. Projections of the vector A along OX, OY, and OZ. You can easily observe that A1, see magnitude A cos alpha is magnitude A cos alpha, from here it is nothing but A1. That is the projection of A on x-axis is A1. Projection of A on y-axis is, that means projection of A on J vector is A2. Projection of A on vector OZ or K is A3. These the components A1, A2, A3 are the projections of the vector along the coordinate axis. A1, A2, A3 are the projections of the vector along the coordinate axis. And A1, A2, A3, A1, A2, A3 are proportional to LMN. Okay? It's already written. A1 is magnitude A cos alpha, A2 is magnitude A cos beta. So that the vector A can be represented in terms of, instead of A1, you can write magnitude A cos alpha. Instead of A2, you can write magnitude A cos beta. But cos alpha, you can write L also. You can write A1 is equal to, you can even write A1 equal to magnitude A into L into I plus magnitude A into M into J plus magnitude A into N into K. Again, you remember that if you have vector A equal to A1I plus A2J plus A3K, A1, A2, A3 are proportional to L, M, N respectively, because A1 by L equal to magnitude by A1 by magnitude A. So A1, A2, A3 are obviously proportional to L, M, and L, M, and N. That means A1, A2, A3 are the direction ratios. If any vector A is A1I plus A2J plus A3K, then A1, A2, A3 are the direction ratios. Direction cosines, each of them divide with the magnitude A. Direction cosines will be A1 by magnitude A, A2 by magnitude A, and A3 by magnitude A. A1, A2, A3 are the direction ratios. Magnitude A plus B squared is A plus B dot A plus B. It is A dot A plus A dot B plus B dot A plus B dot B. A dot B and B dot A are same. We can, and A dot A is magnitude A squared. So we can easily write this as magnitude A squared plus magnitude B squared plus 2 A dot B. And magnitude A minus B squared is magnitude A squared plus magnitude B squared minus 2 A dot B. A plus B dot A minus B is magnitude A squared minus magnitude B squared. A plus B plus C, magnitude A plus B plus C squared is magnitude A squared plus magnitude B squared plus magnitude C squared plus twice A dot B plus twice B dot C plus twice C dot A. If A and B are given vectors, A dot B, then you say what is A dot B? A dot B is 2 ones are 2, minus 1 into 2, plus 3 into minus 2. You can find magnitude A. What is magnitude A? Under root 2 squared plus minus 1 squared plus 3 squared. And magnitude B will be under root 1 squared plus 2 squared plus minus 2 squared. Angle between A and B will be cos theta, where cos theta is A dot B upon magnitude A into magnitude B. Projection of A on B is A dot B upon magnitude B. Projection vector or vector projection of A on B is A dot B upon magnitude B squared into B. Okay, we can easily calculate now. A dot B can calculate magnitude A, you can easily calculate magnitude B, easily calculated. Cos theta is A dot B by magnitude A into magnitude B, right? And theta cos inverse minus x will be pi minus cos inverse x. You can easily find out. Projection of A on B, you can easily calculate. A dot B by magnitude of B. Vector projection of A on B is A dot B by magnitude of B into unit vector, that is B by magnitude of B. A dot B by magnitude of B into B by magnitude of B. Okay. If A dot B is equal to 1, find the angle between A and B if their magnitudes are 1 and 2. Magnitude A is 1, magnitude B is 2, A dot B is 1. What is cos theta? A dot B by magnitude A magnitude B. You know it. So theta is cos inverse 1 by 2, that is pi. If magnitude A minus B is, find magnitude A minus B, if magnitude of A plus B is 27 and magnitude A is 2, magnitude B is 4. You know what is magnitude A plus B squared? It is magnitude A squared plus magnitude B squared plus magnitude C squared. Magnitude A plus B is root 27, so magnitude A plus B squared. From here we get 2A dot B because we know magnitude A and magnitude B. So what will be 2A dot B? It is 7. Now magnitude A minus B squared is magnitude A squared plus magnitude B squared minus 2A dot B. We know magnitude A magnitude B given. 2A dot B we substitute from here. 7. Okay. So this will be nothing but 13. So magnitude A minus B is under 13. And Marcus 2. Find lambda if vectors A and B are perpendicular. The dot product is 0. 3 into 1 plus lambda into minus 3 plus 1 into lambda equal to 0. A dot B is 0. A dot B equal to 0 means you get lambda equal to B by 2. If magnitude A is 3, magnitude B is 4, and magnitude C is 5, and each vector is perpendicular to the sum of the other two, what is magnitude of A plus B plus C? Each vector is perpendicular to sum of the other two means, apart from the magnitudes given, A is perpendicular to B plus C implies A dot B plus C is 0. That implies A dot B plus A dot C is 0. B is perpendicular to the sum of the other two. That means B dot C plus B dot A is 0. C is perpendicular to the other two. That means C dot A plus C dot B is 0. If you add up these, what you get is A dot B plus B dot A is as good as A dot B. Twice A dot B plus B dot C plus C dot A. Twice A dot B. All these are real numbers. A dot B is a number. B dot C is a scalar. C dot A is also a scalar. 0. Now we want magnitude of A plus B plus C. What is magnitude A plus B plus C squared? It is A dot A plus, that is magnitude A squared plus magnitude B squared plus magnitude C squared plus 2 into, and this much quantity we have is 0 here. And we substitute magnitude A, magnitude B, magnitude C, and that is nothing but 50. So magnitude A plus B plus C is root 50 or 5 root 2. Well, you have few questions here. Simple question. Try to do all the questions. Question continues with few more questions. Please try to do all the questions till we meet next. Okay. Okay.